It's a holistic approach to solving problems. You're solving problems, not creating architecture diagrams. You're solving problems. Solve problems that have real constraints, real people affected by those constraints. Focus your efforts on doing architecture, not just learning it. Apply it. Explain it to someone. Write about it. Have your opinion be challenged. Allow your opinion to be challenged in a public forum.
Welcome back, listener, to another exciting episode. In this episode, we will talk about software architecture. And to talk about this, we have invited Denis. He's an experienced software architect. So a warm welcome to Denis, and kindly tell us about yourself.
Thanks for having me. I was really excited to see you slide in my DMs and invite me to the show. I just saw your conversation with Jordan. It was quite eye-opening and very, very interesting. So thank you for your contribution to the community. I spend most of my time coaching and writing nowadays. I've been called a tech influencer recently. Whether that's a good or bad thing, I'm not sure yet. The jury's still out on it. But I spend most of my time and let's say focus on trying to figure out what makes teams productive, what helps them, what holds them back, and then help them overcome their limitations. Oftentimes it's self-imposed. Sometimes it's to do with management style, sometimes to do with architecture, sometimes to do with things like TDD or just how to have conversations, whether that's domain-driven design or solution versus enterprise architecture also sometimes comes in. Yeah.
Right. And I've seen your post like on LinkedIn, like you are doing like an amazing job. Like your posts are very informative. Like, every time when I see your post, I check it and like it's worth, stopping and looking into it. And then on the comments as well, like there are a lot of people, like it's very interactive in the comments as well. So yeah, I would say, you are doing a great job on LinkedIn.
Thank you. That's very kind of you. I do try to do my best to keep the post engaging, and I like having the conversations, which is also why I started streaming recently. So I just open up my camera for 1 hour every week, and then just live stream to keep this engagement rolling with my audience. Because
I've seen your live stream as well. Like it is amazing. And can you tell us about your, your journey other than right now, like as a solution architect or software architect, like what you have done, and like obviously you started as a software engineer, and then like what are the things that you have done in companies? So just give a quick overview of that.
So I started my career in about 15 years ago. I was 18. So once I came to the capital of Slovenia, to Ljubljana, joined university, I figured that university is not for me. I want to get my hands dirty. So I looked for a summer job and I got accepted to an agency, and I just went straight in. So I'm a self-taught developer, and I was always passionate about architecture and design, especially. Nowadays I coach it as well. And I don't label myself primarily as a software architecture. It was just something that always came. It was always in my toolkit. I always needed architecture. Like I can't think of a time where I was a coder, let's say, but not an engineer. So where I would only code things that was already pre-architected for me. Like I don't think I was ever fortunate or unfortunate to be in that situation. So I started off as an engineer, then explored architecture, explored leadership, explored management, went a bit of back and forth. And what I really liked is that sort of tactical, hands-on approach, what you would nowadays call staff engineering, or more of a technical product manager or technical program manager. So there are a little bit of a hybrid specialties, let's say, to this kind of vocation. And I've also heard that the term solution architect being used, or solution engineer being used for the type of work that I used to do. So it's a little bit of everything. Obviously, on the architecture side, I do recommend people check out Roadmap SH and then check out the software architecture track there, because then you get the difference between what is a cloud architect, what is a systems architect, what is a solutions architect, what is an enterprise architect, what is a software architect. So there are a little bit of nuances that, it isn't one size fits all. So I started exploring that, and I figured once the cloud became prominent, I sort of stopped there. I was dipping my toe in cloud architecture, and I said, not my focus. And then I went into coaching. So then I went into this sort of holistic, combining tech expertise with life coaching, and that's where I'm at right now. So that was my 15-year journey.
That is amazing, I would say. And I think you have this personality, like there are like two types of software engineer. One is like, they started coding and then they started coding, for instance, on the front end side. Then like for 10 years, they are just still, working on the front end. Then there are like different guys like who like to explore stuff. I'm also in that category, that, okay, I worked on the front end, back end, then I was like exploring machine learning, then checking like other stuff, architecture stuff, and then how cloud works, what are the different services on AWS. So it is, I would say it is good. And I wouldn't like encourage like any of that. Like it's good like if you have like expertise in like one particular area, it's also good. Like some companies need that, and if you have like that feeling that you want to explore, then solution architect is like or like software architect, system design expert, this is a great field for you, I would say. So what is software architecture and why it is the backbone of any product?
That's a good question. I was always wondering that when I was starting off as an engineer, in the early 2000s, we didn't have architecture roles. And actually, even other peers, other engineers in the field didn't even understand what a software architect is. So I'd have to explain what a software architect does to other engineers, which was quite novel at the time. This was also before the whole UX. We didn't have UX roles, we didn't have product designers, we just had maybe front end, designers, and that was it. Like we didn't have any. We had ninjas. We had front end ninjas for a while, like that whole ninja title craze. So if you ask me, an architect isn't so much. So we need to differentiate the activity from the role, right? So the activity itself, the field, from the title. So somebody who has a title of architect, I would say they are primarily an architect. They might still be hands-on, but I would assume they are either managing the architecture of a product or are managing a architecture guild in a larger organization where their role is similar to that of a staff engineer, where they are sort of managing cross-cutting concerns between several teams, and primarily the cross-cutting concerns of architecture overlap. So that's the role. Now, the activity is essentially everything software related that has to do with decisions. So in this, it might be, you might know ADRs, architecture decision records. An architect would primarily be signing off or at least evaluating those decisions. And then there's also the business decisions. It's like which framework we use, which technology we use. That usually falls in the domain of an architect. But sometimes the CTO is doing those decisions and they are making architecture decisions. Sometimes the engineers are doing architecture decisions. With the whole microservice craze, microservices, I think the bad end of the microservices movement got popular because engineers were rebelling against ivory tower CTOs were doing architecture decisions, and then they wanted to spin up like a new greenfield project so that they could own certain architecture decisions. I think that's the biggest anti-pattern that I see with microservice adoption. But on the bigger part, just to have a simple answer, architecture is basically just a process. Architecture is this continuous process of, we used to call this creating frameworks, but nowadays it's a bit more complex than that. I remember in the early 2000s, everybody's building their own MPC framework, and it was just every business, every team had their own framework this, framework that, and that was we quickly discovered that was not a good way forward. So architecture is basically just an answer to a set of questions. am I fighting my tech stack or am I building my feature? Right. So if I'm fighting my tech stack, what I'm doing is architecture. If I'm building my feature, then I'm living in a well-architected space. Right. If what I'm doing is just I have a feature to add, it's very simple to add. I know exactly where it goes. I don't need to add any new technologies. So that is an example of a good, well-architected engineering space, well-architected project, well-architected product, however you would put it. But the architecture itself, the activity, not the role, the activity is basically an answer to this question. Am I fighting my technology? Am I fighting my cloud setup? Am I fighting my framework? Am I fighting my code design, my code organization? Architecture is the answer to that question. And a well-architected system is helping you focus on the business value of the features.
That is insightful. And I agree with your point. Back in the days, we used to have like all-in-one person. There's this guy, he's working on the front end, back end, and most of these languages at that time, PHP, .NET, they have it combined. So there's one guy who's working on a particular system. And then I also believe like at that time, there was not, that tech revolution that is started now. So at that time, the system are not very big. Nowadays, companies and product which have terabytes of data, petabytes of data, there are number of products. At that time, there are like very few products. A lot of them just, management system, they have like GBs of data, right? And then like it's not like that. Eventually, I believe when obviously this whole industry grew, there are like a lot of systems. When there's like, the system, obviously the code, everything, when it grew, then they needed like persons to decide, okay, like when we are growing, we have like a lot of data, how to basically make proper decisions. Because when you're growing, it is very good, like everyone is so happy, and then eventually the system, yeah, it goes down. So if you don't have like if you don't make the right decision, and if you don't have like system architect, and I would say like people like who make the decision based on what is the way forward, maybe you're not facing a certain issue, but like you will face the issue. So architect will see that, okay, our the latency and stuff. So yeah, it's all related to that.
And I think it's worth mentioning how we came here. Like, why did the architect role appear? Because back in that time period, what the closest thing to an architect were database administrators. And that was a very, let's say, a very noble position, because that was the closest that we got to formal education in software. Everything engineering related, especially on the web, is essentially Wild West. Everybody is self-taught, even the leaders. The change is so fast that we had no stable curriculum for, I think we still don't, with the exception of databases. So let's say the database architects were one of the most formally educated members of a software team, let's say, or a software project, a project management team, let's say. And they were also very self-managed. They were also very much more mature and professional in their way of working, and also very formalized. We see a lot of structure in the way databases are structured that they used to be. Now, again, with the NoSQL revolution and things like cloud-oriented databases, but the new, just the recent breakthroughs that we got with Vitess, with PlanetScale, with Supabase, with databases like DynamoDB, we see a large shift in this kind of thinking, and especially I don't need to mention Kafka, I think, on this channel, and like it is well known, like it is quite a paradigm shift.
Yeah.
But back then it was the database administrator or the database architect that was sort of driving what you and I now would call architecture decisions for the software, because back then most projects, and I think still a lot of projects, sadly, are database driven. You start building up a spec for a system. It's like, okay, what is the interrelational model? What does the data look like?
Yeah.
Or what does the GraphQL model look like? If I flip that conversation around and think about it from the sort of middleware of some kind of federated API that represents a data model.
Yeah.
So I think this orientation about let's try to model the data, let's try to model the concepts, and then figure out how we store them, how expensive it is to store them. Are we reaching any hardware limits because of our decisions? Are we reaching any network limits? Are we reaching any consistency problems, replication problems? Is availability a problem? Is something too centralized? Is something too distributed? Are we on the sort of proper database side assets, or are we on the eventual consistency craze with eventual consistency everywhere, and we're targeting five nines after the comma?
Yeah, I absolutely agree with your point there. And if I get back, because we are getting very deep into that software architect, so someone who does not know much about it, like a viewer who is like a back end or a front end guy, so I will just get the conversation back, and I will ask you. For instance, organization has some new requirements, and they want to design a new system, right?
Yeah.
So what are the initial steps in designing a new system, or in terms of system design, in terms of system architecture? So tell us about that.
I mean, there's no one size fits all. Generally, you'd want to agree on who the major decision makers are and when certain decisions need to be made, right? So, following agile, following lean principles, you don't want to make major decisions about your system at the beginning of the project, because that's when you know the least. Now, the old school way of thinking was, okay, let's think about everything possible very deeply, like rocket science. Like, let's think about, we only have one shot. So let's think about everything deeply, and then have triple, quadruple redundancy, like you have in a spaceship, like the shuttle, and then build it perfectly once, maybe run it, and then that's it.
Yeah.
And then have backup plans or abort plans. That is still relevant for software, but only when what you're building is irreversible, when it can only be built once. That means that so it's not soft, it's hardware, when your software is being embedded into the hardware. If that is what you're working on, absolutely, you need to make a lot of architecture decisions upfront at the beginning of the project by performing maybe some isolated tests, and maybe building up a mock-up or a prototype of the system, and then architecting it, and then building it at the end. But I don't think that's the majority for most of your viewers, most of the people now watching us. Yes, I think you're working on the web, or at least on the backend or front end side, or something in between, or the blockchain, and are architecting something that you have no idea about. And even the people who are creating the business requirements don't have the full picture. So we need to build something in the interim to help us all create new knowledge to get a better picture. Now, the best way to do that is to decide, what do we want to build, and what kind of decisions do we need to make? And then you, as an architect, really, in that kind of environment, your job is to do as little architecture as possible, and to do it as late as possible.
Yeah.
Right? So your best bet is to make architecture decisions when the time is right. And usually that is when you have more knowledge. So a procedure that I can recommend is ask whoever the stakeholders are who have requested the project, ask them what the outcome is. Is the outcome for the first deploy different than the finished product? Do they even know what the finished product will look like, or are we doing an experiment? So what you wanna figure out is what elements will change, what elements will we be experimenting on, and what elements will we not be experimenting on. If the database setup is already known, then maybe you can solidify that, and then you experiment around the database. Maybe the database is not known, so maybe the UI is known, but you don't know the data structure. So maybe you keep the UI the same, and then you experiment on how you communicate with the database, or what the database data, or the shape, or even what type of database you'll be using. Maybe you want to experiment with traditional state-based systems versus event sourcing. Maybe you want to do gRPC or GraphQL, because maybe this is a greenfield project, and you sort of want to widen your horizons, and you know that you will end up in problems that might benefit from using those technologies. But what you definitely want to avoid as an architect is to guess, is to involve too much guesswork in your job, because 99% of the problems can be solved with known, stable, trusted, boring technology. So definitely default to boring choices, figure out if it's painful, and even if you know that it's painful, do a test run for 2 weeks. Experience the pain and then make the architecture decision. Try to speculate as little as possible. That's one side. The other side would be if you're building something cloud native, then you would already start asking questions like, okay, what cloud, why, how much data do we expect? Like, do we need to provision something in advance? Do we want to be in multiple regions? What does the initial deploy look like? What are our sort of goals to scale, to distribution look like, if that is what you want? So the second element to this conversation is definitely sitting down with your stakeholders and getting as many boundaries as possible. So you don't even want to gather requirements, because the requirements will change. That's what they control. What you want is constraints. You want the project to be constrained as much as possible about, we will definitely change this, we will definitely not change that, or we will definitely need to build something within this budget. The more constraints you have, the more your options for architecture are limited, which makes all of the architectures easier to make. Anxiety is the space of, there's too many choices, so I don't know where to go, because if I go here, I'm afraid that I'm closing doors, right? So to reduce the anxiety that the software engineering team will experience, you want to limit their choices as much as possible so that they can focus on the thing that's in front of them.
Yeah, you're absolutely right, and I agree with your point. You don't have to do over engineering and, think about like a lot of things in the start. And as nowadays, like everyone, launch in the market with this MVP approach, that we build like a small product and then we launch in the market, and then they are getting the feedback from the users.
Mm-hmm.
They have surveys, like they launch a new feature, then they ask, or they change the user journey, then they ask for the feedback from the actual users. Because now, obviously previously it was like, the one team or like few people will decide, okay, this is the right flow of the system. Now obviously everyone in the market, they know that we cannot decide, the actual user will actually tell us that what is the right flow. So whenever there is a change, they ask the feedback, and from there onwards, obviously when the system grows. So I agree with your point, like, and then maybe you need to do some changes. And then
Yes.
the most important point is that you need to have some constraint as well, so you're not like going, getting crazy about, oh, I can do this, I can do this, I can do this. You need
Mm-hmm.
to have some constraint. It is very important, and I think it is the job of the CTO or team lead to tell the guys down the road, like, okay, we have like these constraints, so don't get crazy and thinking about this.
Yeah.
A lot of solutions, you have to stay focused on that. So yeah, that is very important. And if we go deep into that conversation, and you can tell about when we are building a system, like how we make a decision of choosing a particular database, or choosing when to do caching for a particular service.
Mm-hmm.
So how those decisions are made.
So if you're looking at it from the perspective of, you're a new engineer, our viewer is a new engineer, they want to go into software engineering, and they sort of, there's so many things to learn, and MySQL and database knowledge and caching systems are usually frequent questions in systems design tests, right? So there are very good GitHub projects that sort of explain systems design to, I think there are systems design clones and primers for the major companies in tech. So there's a lot of research on that. I wouldn't want to belittle the amount of effort that went into that. Just, we can drop a link later for our viewers. What I want to focus on is perhaps this idea of, when is it necessary, right? And how many different forms are there? And where do I learn this from? Because I didn't learn this, at university. I learned this by experimenting. So I learned this by finding a problem, and then I wanted to solve the problem with the tools that I had at hand, right? So let's say my database is slow. I'm optimizing the database. I'm loading a page, and I realized that, hey, it takes 10 seconds to load. Just for one client, just for one page, just for one survey, just for one data set, it takes 10 seconds. So keep optimizing the database. And at a certain point, it became so ephemeral and so arcane that I can't bring it down under a certain number. And early on in my career, I was told, yeah, but like the data doesn't change. So we're doing compute with the database for something that doesn't change. And then I learned about caching, and then it's like, if the data doesn't change, it's silly. This is going back to first principles. If the data didn't change and we threw it away once we served it, then if the user hits refresh, then we have to recompute it to serve the exact same thing again. That is the primal candidate for caching, right? So that is how I would explain caching. If you're doing compute and then you throw it away, if the user refreshes the page and nothing changed, then absolutely that's a candidate for caching. Then you can learn caching. It may be Redis, maybe memcache. There are details here that I won't go into. You could use something you can even use edge functions nowadays, or edge related caching solutions. Or if you're serving your payload through JavaScript blobs, for example, you could use CDNs to just capture them, to give them a unique identifier and just capture them that way. Depends on what you serve. There are also middleware caches or proxies. We have hot proxy nginx that can sort of dump things into the file system, so that if you're doing REST has this idea of having resources. So if I request a resource and it's hard to create, then I can save the output in an intermediary, like a file, like a file on disk or memory or Redis or MongoDB or some other NoSQL database, or just a faster, a faster proxy or faster CDN that has faster SSDs, or is closer to the user, or has in-memory RAM disk. So there are many different ways of how to use caching, many reasons why you use caching. But the most important one is, is the cache LRU? So does the cache evict data at a certain point? Is the cache read through or write through, right? So do you cache the first time the user requests it, or do you cache immediately when it is being written? So there are, again, certain systems that favor one or the other. Sometimes none of these work, sometimes both of these work, sometimes a combination is used. So those terms that I just mentioned, if some of these are unknown to you, to our viewer, I would definitely, this is a good start. What are LRU caches? What is write through, read through, Redis, Mongo, differences to memcached, and just looking for architecture smell. It's like the data is the same. We need to compute it again. The output doesn't change. The input didn't change. So this is learn how to spot those patterns. That's one thing. Then you asked me which databases to pick, how to pick them.
Yeah.
I would say pick whatever the team knows best.
Yeah.
Right. So that is always the best decision. And sometimes that brings you to a local maximum, right? When you say, oh, the team knows DuckDB the most because nobody used Postgres beforehand, right? So it's like everything's done in DuckDB. That might be a bit arcane, So I have to caveat that answer with like use whatever the team knows best. Failing that, use battle-tested software. So that would be your big Cassandra, Kafka, MySQL, Postgres, and then the cloud equivalents, right? So on AWS, that would be RDS or Aurora, depending on which, if it needs a transactional or an analytical database. Then you also have the whole Apache group projects. You have Flink, you have Druid, Snowflake, you have, there's so many, right? Then we're going into this idea of data processing. Is it streamed? Is it batched? Is it ETL? Is it CDC? Change data capture. Then that's nitty-gritty details. Yeah. Generally, what you want with a database, you want to analyze the usage scenarios. Will this be write-heavy application? Will this be a read-heavy application? Will it be both? Do we need it replicated across many different regions? Do we want consistency? Do we want it centralized? and how expensive do we want it to be. Those are sort of the driving factors that you have to consider as an architect. And generally what you would want to default to, right? So ideally, again, we said we don't want to make decisions. We want to make as little decisions as late as possible. So the default decision would be use an SQL database with a NoSQL cache, whether that's a key value store like Redis or maybe Mongo or maybe something else. We also have OrangoDB if you need the graph database. And if you're in the event sourcing camp, definitely consider event store DB or just using Postgres as a JSON store, or you have Kafka. But Kafka is not a durable event store. We need to emphasize that. And for everything else, there's just a big, giant cloud-based SQL database, and you can decide later.
Yeah,
that is the easiest decision.
Yeah.
Like, I have to emphasize that this decision was really important back in the early 2000s because most of the servers were on-prem, and the type of database dictated how and why we are ordering hard drives. So at a large transnational advertising agency that I used to work at, we had a large throughput we used Hadoop with HTable, with HBase, and then we had a large MySQL cluster with MongoDB and Redis replicas. And our primary concern was that we were burning through 2 hard drives every year, which means that two terabyte hard drives could crash and break at any point. So we always needed to have a strategy of how we will migrate from that. So our choice of database needed to support whatever the decision was necessary to maybe restore a RAID field because it might have degraded, and then that impacts all performance across the system. Nowadays, without any on-prem hardware, these decisions are it's mostly system liability engineering, DevOps engineering, or just typical sysadmin stuff that I see dealing with these issues. But this is the problem that the cloud has alleviated. So I would say that a modern engineer starting today should not really be giving this too much attention. You still can. It's still healthy to know all these things. But it's easy to get overwhelmed. I would definitely under prioritize it compared to 20 years ago, and I would focus more on learning, okay, if I put all my data here in the cloud, how expensive is that? And how expensive is me being wrong? How easy is it to just move all my data to some other database or some other cloud provider? And that's really what we want to have in mind, because back then it was extremely expensive. It took a lot of time, a lot of work, a lot of effort, a lot of physical movement. Nowadays, your options are much more open, but it also creates a lot more anxiety because there's so many options. If you're confused, Supabase, PlanetScale, free tier, start there. They will teach you databases. It's cloud-based. You don't have to manage them. The connectors, the drivers to connect to them might be a little bit arcane. That might be a little bit bleeding edge. That's not in the books. But that is definitely a good start for solo projects or just getting into interviews or getting something set up. For a traditional system, definitely one of the cloud-based SQL databases.
Yeah, you're right. And I agree with your point there that in the start, like, you don't have to worry much about, okay, I will store this data in this particular database and this data in this DynamoDB, and I'm storing this in, for instance, a Snowflake. In the start, like, for instance, I have done this myself as well. Like, in the start, we have like just one DB, right? Like, we're using MongoDB, and then we're storing everything in MongoDB, right? And then eventually when the data grows, it has happened with us, like, we are searching for the organization, and then every organization have some players, and then they have stats. And then eventually when the organization number went up to like 17,000, then the searching eventually started like getting slow because it was not just direct query. It was like there was joins with other tables, so it started getting slow. And then what we did, like, we created an open search cluster. We have defined the whole data policy as well, that for this time period data will remain hot, then it will become cold, and then it eventually, like after 1 year, it will delete. So the point is that in the start, because then the client asked me that why you did this and like use this technology in the start, because with open search the latency is like in not even 1 second you can have like terabytes of data, because in some other organization we have like put like I believe 8 terabytes of data, and we are doing message searching in respond.io. So the message search response is like less than 1 second with that much data. But the point is, then I explained to the client, like, for all the viewers, you guys can, learn from this particular case study, that in the start, if I, start putting everything in, like for searching in open search, and then I have some data in Dynamo, I'm using like Redis for caching, then obviously if I have, to build a system in like, for instance, 15 days or a month or 2 months, by doing all these activities, I will, increase the time by 3x or 4x. So, and then at that time, we don't have much data. So it is like not necessary. So it is something that over the passage of time, when, it is necessary, you do that. And as, you mentioned that nowadays it is very easy, even like, to switch your data from, from this particular database to some other database. Like it's easy. Now there are even tools, or you can yourself like create like a script and do this. So yeah, that is, I would say it's not a big deal now.
I like doing domain-driven design. And with domain-driven design, what we really want to focus on is we want the business to accelerate how quickly the requirements can change. Right? Because as engineers, our comfort place is, we got the requirements will never change. And then we'll even enforce, no, you can't change the requirements because I'm not coding along the requirements. But that's not what the business wants. See, every time the business responds to market feedback, the requirements change. And that's a good thing. That is a sign of a thriving, healthy business that is being agile. That means that you want to encourage the business to change requirements all the time, because that means that they are making mistakes and learning and course-correcting very quickly. Now, there's two camps to this. There's one camp of architects, engineers, and designers, I would say, generally, systems designers, which say, once we design something, we should never change it, right? So once we set an architecture in place, we will make the architecture the expensive thing, and then this we never change. So we make it add only. So this will never change, and all the new things we just add around it.
Yeah.
Right. So it's sort of like a traditional SQL-based approach, but event-sourced. So we don't update any of the SQL tables. We just keep adding new ones and build on ones already there. And the extreme equivalent of that is a whole anti-corruption feature freeze on a database, and then you migrate that slowly through change data capture, through some event store or message queue to another kind of database, right? While it's running, while the application is writing to it actively, right? So you sort of use the write-ahead log to create a living replica from it. These are like common strategies of how to refactor something that you said you will never change. So there's the camp that says this is expensive, so we will make it not changeable. So we don't want to change the schema. We don't want to change the database. And there's the other camp which says, nowadays it's so cheap to change it that we want to keep changing it all the time. And that's the sort of micro or even nano service community, which says, I don't want to have a large database because I don't want you to be coupled. I don't want you doing joins on my database because I might change my database or I might change my table. So I will have 7 tables out of the 100, and the other 93 have to talk to me through an API so that I can change my tables whenever I want. So this is the more refactoring, emphasizing, sort of engineering-owned, microservices-oriented kind of camp, where you say, okay, the business requirements might change. Whatever I'm doing now is probably wrong. So I want to preserve the freedom of changing the internals while agreeing that there is a contract, a boundary, an external, which is maybe an API or GraphQL, maybe some kind of protobuf or gRPC connection, or maybe just a schema of events. And then that's my interface. And you pretend that that's the database, that the API is your database. right?
Yeah.
You can't do joins, you can't do large sorted joins and join merges. So you have to have sort of a compute already there. So you have to have something that is thinking, not just storing data. And that's the more modern application way of doing architecture. And now most people will be somewhere in the middle. Most people will say, "Ooh, that's really hard to change. I never want to change that. I never want to have requirements change in that large table that has 47 columns. But I might want to keep changing this experiment we're doing now. So maybe I won't put it in the same database, or maybe I'll do a logical partition that's slightly different. So it's still in the same server, but it's not sharing that old structure. Maybe I have a MySQL database here and another one here, just so I have a little bit of logical separation, or maybe even physical separation. So that's the more expensive never change versus refactoring heavy. And this is a self-fulfilling prophecy. The engineers who have been more classically, traditionally brought up, they would say, oh, the database thing is the holy grail. That is the one thing we don't change. If you have to refactor your database continuously, you're doing something wrong. That's the waste, and that is a bad habit, and you should stop doing this. Yeah. And there's the other camp which says, well, of course it's changing. This is a thriving unicorn startup. We will keep changing stuff and keep breaking things. So try to decentralize data as much as possible, and then let the hubs and clusters of compute and data figure out between each other through some contracts or protobufs how to make their lives as easy as possible, while everything in the infrastructure level is constantly changing because we're growing or because we're scaling. Maybe it was one database, now it's one database per region. Then that's a problem. Now it has to be at least two databases per region across multiple availability zones, right? So maybe we grow so much that we now need high uptime as well, and then we do maybe continuous delivery, and then databases become fragmented, and data corruption can seep in, so we have to do conflicts of some kind. So there's these two camps, and it's very, to not go too deep on the philosophy of this, it's very important to understand that there's nothing wrong with either extreme. These are tools in our toolkit, and it's okay to say, I don't want to change this, I do want to change this. What I would emphasize is that saying that this X something should never change and cannot change, that is always a bad architecture decision.
Yeah.
Because then you're forcing the business to either tear it down, rewrite it, strangle it with this, strangle fig pattern, or to avoid it with some change data capture. So the business will always go around this idea of, yes, we can't change this, but we have to. Right? So the decision of this cannot be changed cannot be enforced. So cannot change, must never change, just means it's very expensive and impractical to change. Right? So in modern times, I would discourage architects to think along that extreme. Right? So I would rather say, learn how to spot code smells, database structure smells, schema smells, and systems design smells. Write and read loops should generally follow in a loop, not bidirectionally. Bidirectional read-write loops imply that there is hierarchy, which means that uptime is dependent on the least reliable chain in the link in the chain, while also being susceptible to all other failures along that chain. That is one thing. The other thing is, we don't want to encourage too much knowledge siloing going on. So when you say, oh, this is the database and it has to be like this, and you have to use this ORM to read from it, and that then forces architecture on all the other teams that are using this, and then that's enforcing architecture in their SDKs, and then the SDKs are enforcing architecture on how they build their UIs, and then the database architecture now forces the designer about how they think about that new flashy landing page they're about to create, right? So that is exactly what we don't want. We don't want that conformist integration seeping out from large architecture decisions, because then you get called an ivory tower architect and you're probably over architecting. That doesn't mean that your work is bad, but you might be making too many decisions, perhaps out of insecurity or out of fear that you might be judged for not making a decision. I think as an architect, your responsibilities and experience and respect will increase with the amount of decisions that you don't do, right? So when you can confidently say, we should not make this decision right now.
Yeah, that is true. Like keeping the things simple is also very important. Like because as you mentioned, like both extremes. Some guys say, okay, like this is the architecture. We will not, put hands on it. It will stay the same. And eventually, obviously, when their data grows and after like many years, they start facing the issue. But on the other end, there are like certain guys. They are like checking out new technology. Okay, there's like a new database, graph database, Neo4j. Oh, this looks, very good.
Mm-hmm.
Everyone is talking about it. Okay, let's, in my system, maybe it's not like your use case is not relevant to that graph db, but it's like sort of relevant, but it does not necessarily you have to change something. So your point is, I absolutely agree with that. So you don't have to, if you don't take the decision and if you keep the things like that the way they are working and they are not, there isn't any issue, so it's good. Like you don't have to over engineer anything. So then in that way, like everything is, in case you face latency, some issues and things are growing, then you have to make these decisions. And with that, I get to know, like I have this thing that I want to discuss with you. Like we are talking about different databases, caching, the changing in the architecture. So what is the role of monitoring in all of this? Because obviously we need to monitor, and how we decide, obviously, that we have some latency, that for instance a guy in US, for him the system is working absolutely fine, but
Mm-hmm.
there's another person from maybe in Malaysia, right? For that guy the system is very
Mm-hmm.
slow. And then there can be a case like there's another person in India, they are facing errors. So how we get to know about this? Like obviously the monitoring comes in the picture. So tell us about that.
So on monitoring, the most popular monitoring tools that you probably are using are Sentry and the Elk stack. Elk standing for Elasticsearch, Kibana, and Logstash. You just Google those two, and I think you might be, maybe you use Prometheus or something equivalent, or maybe your cloud provider has something equivalent. I don't want to bore you with the details. What's really important regarding logging is that we always need to log the entire value stream, right? So the value stream might be the user is using some application, they are getting some notifications, there might be a web protocol, all of those are maybe connecting into some distributed servers for compute, for backend, and they might have caches, and then they might be hitting 2 or 3 replicated databases. Things will go wrong. This is a complex system. So for logging, really what we want to find out is that when something goes wrong, you want to have tools at your disposal to figure out where was the root cause for the thing that happened. If the request is slow to the user says, hey, it's loading forever. Okay, what's the problem? Is it a server problem? Is it a backend server problem? Is it a network problem? Is it a database problem? Is the database read problem? Is the write problem? Is the caching problem? Is it just this user? Is it just this region? So what logging allows you to do is, nowadays there is this concept called tracing, where you would have a sort of this idea of a span or a trace, where you say this is a user and the user's request is hitting several servers. And then there's a unique identifier capturing that specific intent, that specific request of the user. And that trace is then, it's being used in, let's say, C# or in PHP or on your serverless functions and your database and your message queues and your front-end application, right? So it's all using a certain trace ID or span ID. And then what you really want is that you want to gather these logs, because you don't know when you'll need them. That's the worst thing, right? So you're not monitoring it live.
Yeah.
You don't know when you'll need them. So what you need to figure out is, when you get a report from the logs, you want to figure out, oh, a user reported a problem yesterday at 5 p.m. This is the user ID. You want that is usually the most information you might have.
Yeah.
And with that information, now you need to figure out, okay, what was the state of the system then? Right? So as your application is running, as an architect, you need to be thinking about, okay, how will I have oversight about, let's say, it's like having a security camera. You have a recording of the last 24 hours. It might be low quality and no sound, But the only reason you're using it is that if there was an incident yesterday or a break-in, you now have enough logs to really check if you need to, right? So you want to sort of kind of want to predict if there's a problem, you will have, let's say, 72 hours to go back and look at everything that's there. And nowadays it's easy to just keep recording everything if it's just text logs, because you can rotate them and compress them. And you want to really figure out, okay, what was the user hitting? Was the user load balanced to some server they shouldn't be? Was there a, were we being DDoSed? What was the problem? And then ideally what you want is you want your logging system to give you a view into that timeline. You want to be able to go back and see, okay, I want to isolate everything not related to this problem. And I just want to look at the user's flow and try to figure out whether there's some patterns. Generally, what you'll be doing is you'll be looking for patterns of, was there a CPU usage spike? Was there a disk write usage spike? Was there a disk read usage spike? Did we blow one of our network routers? Did we hit egress limits? And sometimes the problems are artificial. Sometimes, if you ever worked in the cloud, you will know that for those servers that have CPU credits or usage credits, once you hit those limits, you have two options. They might start billing you more, or they downgrade you to a default instance, right? So the reserved amount that you had is gone, and now you're being downgraded to a very small system. And usually what that looks like in the CPU graph is it goes like this, and then it goes doof, doof, and then when you're downgraded, you're like at 100% all the time, because you didn't build the system expecting that you will be running on the downgraded server. So if that can happen a lot in the cloud, and it creates really weird logging patterns because the server is changing as you're running the system. So what you really want to do is you want your team, maybe your other architects or just engineers, to have as much data as possible at their disposal when they are debugging something that at the system level. Specifically, when they're debugging something that cannot easily be replicated in like a localized dev environment. So it can be covered with like in-process testing, developer tests, acceptance tests on like a local machine or a staging machine. Sometimes root causes of certain bugs and performance problems and issues can only be found on the production server, and they need to be tested and monitored on the production server. So you will never know in advance what you'll need. So you will build an intuition over time as an architect on what to log. Generally, you would want to log things like, this has started, this has stopped. There is an unusually high memory usage here. You might have SLAs, some requirements, contractual obligations of, the request always has to be this much. If you ever worked at a fintech or at a what is it called, an algorithmic trading company, you will know that requests have to be responded to within a certain time frame, and then you would want to log slow responses. In a SQL database, you would generally have a slow query log, right? So you would log everything you want, and also here are the really bad outliers. In any kind of application that you care about, what you want to log is when you predicted that something exceptional has happened. So generally, exceptions, security violations, something very rare that shouldn't happen, and you just want to log it because you don't know how many different ways it can fail. Sometimes your server can fail because the hard drive is full because there's too many logs on the hard drive, right? So that's also an exceptional situation. It's like, I want to open a connection, but I can't because the hard drive is full. And then you'll see an exception for the first time that you've never seen before. And that ideally you would want to have logged. So that's logging. For telemetry, I recommend just go with whatever your business needs. There's so many SaaS solutions now that sort of give you telemetry in the cloud. I've already mentioned a few, and the big FANG companies usually use in-house tools for that. So there's no need to learn anything off the bat. Just know that you will need something, and if you're the architect in charge, you will need to learn one of them. And usually all of them are good choices. Like, there aren't really bad logging solutions out there, because all they do is logging, and logging and visualization. So the only criteria there is that maybe you picked something that's unnecessarily expensive, or it's ugly and doesn't match your subjective criteria for how the charts look.
Yeah, I agree with that. And just to, sum up what you have said on that monitoring, like I have also used both of these tools, like, Sentry and then the ELK stack. So for someone, like who has like a small product and they do not have much time to, integrate monitoring, anything, then I think Sentry is the best tool, like, because it's like a 4 or 5 line snippet that you have to add in your code base. You
Yeah.
have to make an account, like I think within like very quickly you can integrate Sentry, like in your whole application. It might take, one day if you have like microservices. Still, like it won't take much time. You just, create applications on Sentry, then, add that snippet, you're good to go. And then on top of that, it is not like just Sentry is like very, simple tool. It has, proper monitoring. Now they have also introduced like metrics for performance as well. Like for instance, your API
Yes.
is getting slow, because I have talked to them. I had like multiple calls with Sentry, and then in there they explained me like a lot of things. And then like they also have added feature of cron job monitoring. It is very useful for me because we used to
Very.
sometimes miss that cron job, and from logs it is very difficult. So from there, like,
Yeah.
dashboard of crons, you can see, okay, for the past like 7 days, our cron job is, getting started, and okay, it's everything is going fine. And then when it started, when it ended, you can also see that, okay, my cron job take like 10 seconds or like 30 seconds to finish, like what was the process. So if it is, getting longer, the duration is getting longer, like in hours, then you get to know, okay, I have to create multiple servers. So it's good. And then like other than that, like on the front end, it has like I would say like the recording as well. It's not like the actual proper screen recording because of obviously privacy issue, but like still like it's a good recording. And then you can see the logs as well. Like for instance, if a person calls you, and it works very well in the beta testing, like
Yes.
because it has happened with me, like in the start of the project, like there are like very few users, like 100. It's the project is in beta state, and then using it, they just message me, and then they tell us, okay, this is the I was doing this, and then I faced this issue. Then from that, I just check their whole session. I was checking their console. Oh, this scenario, there was this issue. So yeah, it is very good. And then obviously, if you are in a team and if your product is very big, obviously then Sentry has their own limitation as well. Then it is best to go with ELK suite because it is very powerful. Like Kibana itself, like it's very good. And then like
Yes.
when everything combines, then you can obviously, that is like the customized solution. It is expensive as well on the other end, but you can integrate that with, like, we have done integrations with like notifications to Slack, notifications to PagerDuty, and on PagerDuty we have the notification for clients as well, all the customer facing side. So obviously there's like a whole new thing, that because it has like a lot of features, you can create charts, dashboards. So but you only need that when you have a complex application, because otherwise, because it has a learning curve as well. For instance, you are already using like Elasticsearch, OpenSearch, all of that, then the learning curve might be less. But if you're not familiar with all of that, then obviously there you have to learn all of this and integration, everything. But on the other side, it also create like charts as well. Like just by getting your request, it has like, it creates chart. Okay, the request come, then goes to this particular service, this. And when I saw that particular feature back in the day, when I saw, I was like, oh, that is great, because it sort of created that diagram, architecture diagram for me, that this is how it works, this is how the services are communicating with each other. So yeah, that is I would say that is good. And these are also, I would say there are other tools as well, Datadog, some other as well, but like these
Yeah.
two are, I would say, like, yeah, the most famous one.
Yeah. What I would mention is focus on the basics. Right. So this whole idea of monitoring comes from debugging.
Yeah.
Right. So back in the 80s, 90s, 2000s, we learned how to use debuggers. Nowadays, I tell people, don't use the debugger. If you have to use the debugger for something local, you should be writing tests for that. You should not be debugging manually. The automation should be debugging for you by you having written tests. But what monitoring allows, so what we just spoke about, that's debugging live in the cloud. But obviously it's too complicated to spin up a debugger because there isn't any one runtime that you need to be, jacking into to debug it. There is millions of it and millions of servers, and they might not even be physical servers. They might be, shards and replicas of servers and little virtual nodes where it would be inappropriate for you to have that level of access because it might be on some, Amazon's infrastructure or Azure's infrastructure where it is inappropriate for you to be having that kind of level of access. So monitoring is your way of creating something that you can use as a debugger for your production server. So that's one thing. The other thing is just learn the basics. And here I'm very strict about just learn good GNU Linux basics. One of the best things that was ever invented in that ecosystem was a command, a application, but we usually think of them as commands, right? So any bash tool, any library that you do, they usually follow a very strict interface. Standard input, standard output, standard error.
Yeah.
And if you can get all of your major architectural pieces to follow that interface, your life becomes a lot easier. Because standard input might be what you send in, or it might be your network interface. Standard error is always for the human, and standard out is always for the machine. Sometimes there's exceptions, but that is the default, right? So generally think about it this way. If you're building an architectural Lego piece, regardless of how large it is, it might be a class, it might be a function, it might be a Docker image, it might be an entire swarm, it might be an entire Kubernetes setup, depending on how you're terraforming it, or it might be just one server that has several processes in parallel. If you get the Lego pieces in this format, you can always say, this is what the machine waits for and responds to, this is what the machine outputs, and this is what the machine is communicating to the human, right? So always think about your application as having 3 pieces, not 2. We like to think that pure functions have input and output.
Yeah.
But your application should always have, when you're following the code, when you're following the architecture, they should always have 3 pipes. What's going in, what's going out, and how is it being observed? How is it being monitored? That monitoring pipe is the most important, right? Because that's how sometimes engineers ignore this, architects ignore this, and then monitoring is either tacked on to the input pipe or the output pipe. And this is what engineers mean, that monitoring and telemetry is an orthogonal concept. It's supposed to be orthogonal. It's supposed to be cross-cutting. It shouldn't impact your inputs. It shouldn't impact your outputs, right? It should be an entirely different channel of communication. And you have to plan for that. So don't try to make your Lego pieces have left and right and in and out. They need to have at least three channels to be useful. And that's very important because it's not a perfect shape. If you ever play Tetris, that's not the most favorite piece. So keep those basics in mind and try to architect any kind of solution, any kind of piece, any kind of boundary, any kind of service, any kind of server, any kind of node in that shape. This is what it responds to. This is what it generally outputs. And this is how we monitor it. This is what it monitors to. This is what it represents itself as.
Yeah.
And then on the basics, on the actual architecture side, there is no preferred tool or diagram or document. Just start. Start with a document. There are templates for architecture decision records. There are many open source GitHub projects which now capture these very well. Even those, if you have a favorite company, you can say, okay, how are these records being made in Amazon? How are these records being made in Spotify? You can find them. This is public information, right? So don't try to reinvent the wheel. If you have a role model, let's say, just look up what they use. All of these major companies have engineering blogs. Just look up what they do for architecture documentation. I use event modeling a lot because I find it just hits the spot on technical jargon, and then I can use it to communicate with non-technical stakeholders. Some people like C4 diagrams. Some people like what they are given by their cloud provider because it might have a diagramming tool. Some people like writing in documents. So like a Word document, a Google Drive document, rather than doing diagrams, and then they sort of have diagrams be made by designers or generated by some tooling. So this is all good. There isn't any silver bullet approach. You will definitely not be judged on the design of your diagrams. What is most important is that these diagrams are easy to keep up to date. That is the most important part. If it's hard to make, if it's annoying to make, if you have learning to do, if it's painful, do it more often. Do it more often so that the diagram becomes very easy for you to make.
Yeah.
Right? I like to use Excalibur and Miro boards. It should be easy to change primarily. Don't overinvest into a diagram. Only you, the architect, will care about that particular diagram. Nobody will ever look at it as much as you do. So don't overinvest into it.
Yeah.
The best success metric for an architecture diagram is that nobody has to look at it. At the same time, the worst success metric for an architecture diagram is that nobody is looking at it because they might not know that it exists and that they have important information in there, right? So this is something you will have to build an intuition for.
Yeah, I absolutely agree there, because now a lot of companies have their documentation on Notion, and then they have, like, description of what is this, and then they have diagrams. They even in, I think, Notion, you can embed the mermaid syntax diagram and stuff.
Yep.
And I think, yeah, it's good. Like, and I also believe like the diagrams should, like, simplify it. Like if you see a diagram, like as a developer, and like you joined the company and you want to understand like the process, you should just have a look at the diagram, and it shouldn't have like a lot of components so that it is very confusing. Then you call another person and to explain me
Yeah.
this, then that means that the diagram doesn't serve the purpose. So as a dev, you should see the diagram and say, oh, the flow start from here and then goes there and goes there. Okay, like this is how it works. Like if you talk about any diagram, sequence, event diagram, like block diagram, whatever diagram it is, it should be, I would say, like simple as well. If it is very complex, then divide that into multiple diagrams. And then your point, like the diagrams will be, the as a solution architect or as a new dev joining the team, and that guy, want to understand the whole system, because a lot of dev, they're like, okay, I'm working in that aspect, I'm not interested in learning the whole bigger picture, so they won't be looking at it. So yeah, from there, I will, in the end, want to, emphasis on the system security, because this is like a very crucial aspect of the system. And then if you talk about, the systems and applications that are being used in Europe, like they have this GDPR policies as well, that your system, if a person requests for data deletion, if the data got stolen, what, there are like a lot of things in that as well. If your system does not comply to that, you get heavy fines as well. So a lot of companies, I have seen that they do not compete in that market for that particular reason as well, that their system is not like battle tested for that. So yeah, I wanted to know, like, more about that, the security and compliance aspect.
So to keep it short, GDPR is not a big deal. The fines are not as large as long as you're small. So if you're running an experiment and you have GDPR compliance issues, then it's very easy to comply with GDPR. Right? Now that's about compliance. Now, if you have a data breach, that's always a problem, regardless of whether you're in Europe or not. But GDPR just generally says that you shouldn't pass user data without their knowledge. You can, but not without their permission. And there are some defaults where you can do a lot of things with the data in good faith, as long as you have communicated openly that you are doing so. And usually people just avoid the market because they don't want to create that one legal document. And that's a very easy legal document to create. And there's services for that online. But on the aspect of personal data, generally as an architect, what you want to be looking for, especially for a Europe-centric customer base, is that you want ideally personal So information that can be used to identify a person, like a name, like an address, like an email, credit card, whatever. You want that to be stored ideally in a vault in your architecture, and limit the amount of unnecessary copies and caches that are being passed around the system. That's the major thing regarding GDPR. And then once the request comes, you don't even have to have it automated. You just need to have a formal procedure, even if it's manual. It can just be a Notion document, a formal procedure of what you'll do once you get a request. Caveat, of course, if you're a small business. Enterprises are a completely different category here.
Yeah.
But again, enterprises will also have an entire security team and legal team and privacy and data privacy team and information team. So that's outside of the scope of a single architect to handle. As an architect, what you have to know is, I think you should just generally be looking for the major security threats. You don't want to be ready for everything. Just, it's very easy to look up on the internet. Check the major security threats, because most of the major security threats can be avoided by very simple basics. You keep the hygiene up on basic stuff and you're good, which means using secure connections whenever you're crossing a network boundary. Internally in your system, perhaps not. It might be a good practice to have your internal network at least firewalled, encrypted, maybe the hard drive is encrypted when at rest. That's also, again, SOC 2 certification and other kinds of, you might need it for PCI compliance or fintech compliance. But as far as the security is concerned, just keep it the basics. Learn the basics as an architect. Secure data, encrypt or hash really sensitive data like passwords. Maybe avoid sending them over the wire, unhashed, unencrypted. Then there's the aspect about avoiding encouraging man-in-the-middle attacks, right? So don't make it impossible to inject code into your front end, make it impossible to inject code into your back end, make it impossible to inject code into your database queries. And that can always be done by verifying that any input that comes from the outside world that's crossing your network boundary is verified to never execute inside your code base. So that's the sort of parameter sanitization as it is known, but sometimes it can be a little bit more harmful than that. Sometimes it can be, like uploading something to if a user uploads a file, don't store it in where your code base is. If your user can say where on your server it should be stored, don't let them control the full path, because they might say, okay, go to / and var www/html and replace that PHP file. Just have sane secure. And if you don't have a lot of experience as an architect, it's impossible for you to know all of these little tricks. So if you're not into security, learn the basics. The basics are enough. Yeah. And then once you grow, you will actually get real problems, and then you'll have a security team assisting you. If you're into security, what I would encourage you to do is to attend various hacker group conferences, so white hat hacker conferences, and learn how systems are hacked. And that will, go on the other side, learn how vulnerabilities are being exploited, because they're super fun. There's a lot of competitions on this. And encourage your system to be hacked. Maybe even set out bounties. Encourage people to try to hack your system, because the more you hack your system, the more resilient it will be once you respond to benign threats, right? So if you ask to be hacked, then you can ask to be hacked by a good actor. So once they hack the system, they will not disclose it. They will just privately contact you and help you fix the leak, help you fix the security issue. That is how a mature security minded architect will be thinking about this. But definitely don't try to think about the problem. Just encourage people to say, this is our external API. Is there a problem with it? And then you just try to brute force it with common techniques that you probably don't know about, but there are certain services and experts that you can hire very cheaply to just do penetration testing against your major vulnerability areas. Browsers already have like linters and testers, Chrome and Firefox. They have a lot of Lighthouse and performance that will tell you the obvious little things, like this is not compressed, this is not encrypted, this is going through some other subdomain, this is susceptible to man-in-the-middle attacks. Here is a little you're posting this variable, HTML is being served from the return value. It is not coming from a secure domain. Cookies are being stored universally, not in the correct domain. Cookies are not secure. You're not using HTTPS. So the browser itself is already a strong tool. And then you have your build tools for the backend, or build tools or verification tools on the cloud. When you upload them, they will also come with security checks. Don't ignore them. Encourage your team to say, what is the security check? I don't know. Okay, look into it. Is it a problem? No. When will it become a problem? If we leak, what are we leaking? Oh, just a few logs. Okay, fine. Is there anything sensitive in those logs? No. Okay, cool. Then, just know what the blast radius of a security problem are, and try to fragment it in good faith, not obfuscate, but try to fragment your data access points to the degree where it isn't just one giant barrier, and then if I get access, I have access to everything. Fragment your data usage in such a way that you have several checks, several boundaries that you have to go through, and you go from light to heavy. So the personal information that is very secure, the credit cards, the personal information in Europe, that should be on like the hardest line of defense. And maybe the best way to secure a server is for you as the architect to not have access to the server, right? So encourage engineers to not debug the system by having root access to the server and having write access to the production database. Encourage them to use tools. Encourage them to write their own tools that will help them debug and monitor and do telemetry and security easier. The more you can constrain access to, needless access to the system, the better it will be. But again, 99% of the security problems are social engineering phishing attacks. So two-factor authentication. If you have access to a server, absolutely two-factor authentication. You can have the most secure server in the world. If your phone gets stolen and somebody logs in with your accounts, all hell breaks loose, and it's your fault. Like it's a very easy, avoidable problem, right? So just before you do any kind of security nonsense, outside of the basics, you please use two-factor authentication for everybody who has root access to the main systems, and then encourage your users to do the same. That is the best thing you can do. That is the best ROI for any kind of security hardening that you can do as an architect. Anything beyond that is, I would say, expert level and will require or already has a security team.
Yeah, I agree with that. And I also suggest, on top of what you said, like just look at OWASP top 10 for like web
OWASP top
or
10.
mobile app, right? And then like a lot of these time, like I have worked with like a lot of pen test companies and guys as well, and what they do is, like, if you give them your system and you say, okay, just test the whole system, they will check the whole system based on these OWASP top 10 most of these time, and then they give the report that, okay, your system DDoS attack, we cannot do it. Like, they will first check the DOS, then DDoS, then they check like script injection. They will have that, this test we executed on your platform, this was the result. This test, and these tests, as you mentioned, it is not very difficult. Like, even if you want to identify that, there are like different tools as well. Like Google Chrome has some of that. OWASP Zap, it's like, it will also tell some of that. Then if you go into more detail, like Burp Suit, I use personally as well. Like, you can do a lot of things, like even the man in the middle attack, you can also kind of simulate that and then check, okay, the SSL pinning is working or not. But most of these things, if you just write everything, the code, everything, if you have done like good in the start, maybe you won't face any issue. Maybe you already have a middleware for sanitization and stuff like that. Maybe your system is already for, in terms of security, it is already good. But in the start, if you do it, it is very easy. But if the system grows, then you have multiple services, then it kind of get difficult. But on the other end, it is not very difficult thing if you have like proper good knowledge, and then you take the OWASP as a, I would say, checklist. Like, okay, these are the top 10, I have to check that, I have to create a particular test case. If it pass, I will just take, and then you can with like confidence say that my system is secure and there isn't any problem. So yeah,
the important part to emphasize, to bring together our conversation here from the beginning, about that camp of this should never change. What you definitely don't want to do is to create a system at the beginning which is not secure, which doesn't follow best practices, and build it in such a way that it is hard to change.
Yeah.
That is the thing you're avoiding as an architect, right? So you don't want to make it quick and dirty, cheap, hack together, and hard to change.
Yeah.
Because what you absolutely do not want to tell your users or your CIO or your CEO or your CFO is that now we need to do security hardening, and our architecture prevents us from doing that. If I add secure connections, all hell breaks loose. If I add two-factor authentication, we'll need to change the entire app. If I add, if I get a GDPR request, everything breaks. I can't remove users from my system. That's silly, right? Like, that's the worst case scenario that you need to have on your map, and just be adamant as an architect of that is where we're definitely not going, ever, for no reason. There is no value being gained there. We're not going faster, and regulatory laws, GDPR in Europe, there's an equivalent in California. I think India is now implementing something similar. If you're in the Chinese market as a European, you're not susceptible to it, but if you have a Chinese company representing you, it's even worse. They have the most privacy setup for their own citizens. And it's also the same thing if you're Russian, and then it has to be on Russian servers, and then like it can get really complicated really fast. What you want to avoid is just, oh, it was done in this way and it always has been this way. It's very hard and very expensive to now make it more secure and easier to, and more privacy compliant. Now that's just know what hell looks like and agree that you won't consciously go down that path. And that's the best thing you can do as an architect, because then all the other paths will not be known to you, but then you will research them in good faith and know that you're running the right direction, because there is just one very obvious bad decision, which is not secured, no idea what's going on, and hard to change. Once you know that those three are the holy grail of what to avoid, don't go there. Everything else you can decide later, as long as you keep some seams, some elements malleable enough for you to undo bad decisions. And that's what you want. It's really important as an architect. Encourage your team to make bad decisions, to make mistakes. Have your architecture decisions be reviewed. Have them be challenged. Encourage your architecture decisions to be challenged. Because if you're getting challenged of, oh, I don't think we should have made this decision, absolutely don't make it. Your team knows your system better than you do. Right? You're just there to make sure that it's in sync with all the other teams, that what they're doing. If you're that kind of architect in that kind of organization, if you're the CTO, try not to micromanage your team by doing architecture. That's the best advice that I can give to any new engineers who want to become architects, or anybody who is wanting to come into software and become an architect or solutions architect or enterprise architect. Definitely understand that at a certain level, it's about you admitting that you don't know, and deciding whether this decision should be made now, or whether, what is the risk of making this decision later. That is what you primarily want to communicate. And the other aspect is you will at some point become a specialist for domain knowledge. So you might be, I don't know, you might understand a certain aspect of Salesforce's database model, or you might understand a certain aspect of how to integrate with Kafka or other connectors to some third-party libraries, or you might be very good at Facebook or Meta ads integration, right? So there will be data and communication aspects to your work where you will become an expert just by exposure. Like, you will become good at them. That will also define your career in some way, in a good way. But it's really important to understand that you as an architect have got to that point because you were allowed to make mistakes and learn and sort of undo certain architecture decisions safely. So don't be the smart person who has all the good choices, because you got to your good choices by having experience, and you got to your experience by making bad choices. So don't force only the good choices onto your team. Let them do their bad choices, because then what you want to encourage, you want your engineers and the people who are working with you to also understand and learn and better their own architecture skills, so they don't have to rely on you. Don't silo knowledge.
Yeah, that is
serve them, don't control them.
That is an amazing advice, I would say. because I haven't thought in that manner as well. Like, because it's let them make mistake, and then from their mistake they will learn. So that is good, because obviously if a person has like a great knowledge, obviously how they get to that point, they have like done a lot of bad things, and then if you make a mistake, then you obviously do a lot of search, and then you like, I don't have to do that, and these are the alternatives, and so that makes you, a better person. So in the end, like, I would like to ask, what is the final piece of advice from your side for the emerging system architect or system design expert?
I would say get out of your bubble. If you don't have a job right now and you're watching this video because you want to get hired, and don't waste time doing katas and systems design and trying to come up with some novel solutions that you will only have for your portfolio. Try to join an open source initiative. Try to join a real problem, a real company where, or if nothing else, make it educational. Teach architecture to other people. You will learn the most when you can explain the concept, not when you come up with good architecture. See, the problem with good architecture katas is that there is no good architecture in absence of hard business and market influence. So if I give you a to-do MVC app, or if I tell you, give me a clone of Calendly, you don't know how to architect that, because you have no business constraints. You have no market constraints. You have no budget constraints. You have no time constraints. So you're missing out on all the important pieces of architecture work, the activity that we mentioned at the beginning, that really define a good architect. So don't rob yourself of that experience. Try to reach out to other architects, learn from them directly. Try to join their teams. Try to join companies where architecture is appreciated.
Yeah.
Try to monetize your learning experience. Join a company that will encourage you to learn it. Join as an engineer and say, I want to become an architect. Maybe you are an engineer right now and you want to become an architect. Don't job hop. Communicate that to your manager. Create that learning path for yourself. When I started off in my career, almost 20 years now, a lot of these roles that we now occupy didn't exist. The roles were created. In the future, new roles will be created. Now, with the advent of AI, it's possible that in 5 or 10 years, we'll have AI vector database architects. Maybe we'll have LLM architects. Maybe we'll have data engineering architects that are working in some way with integration applications for AIs, or how to get AIs into this data flow, into that data flow. Maybe that's where we're headed. I could be wrong.
Yeah.
But don't rob yourself of your learning experience by isolating yourself to just nailing the interview. It's a holistic approach to solving problems. You're solving problems, not creating architecture diagrams. You're solving problems. Solve problems that have real constraints, real people affected by those constraints. And to wrap on that, focus your efforts on doing architecture, not just learning it. Apply it. Explain it to somebody. Write about it. Have your opinion be challenged. Allow your opinion to be challenged in a public forum. Contribute to something to open source communities. And by and far the best architecture advice that I can give you is check out Roadmap SH. There's a software architecture roadmap for all the different nuances of architecture, and try to figure out whether you even want to be an architect. Because maybe you want to be a staff engineer and you just don't know what the role means. Or maybe you want to be an enterprise architect, but maybe you want to be hands-on. So maybe an enterprise architect isn't that. Maybe you want to be a solutions architect. Maybe you want to be a solutions engineer. So try to figure out what are the nuances to software architecture in the company, in the industry, in the type of, maybe is the startup, is the scale up, is the main company. Try to figure out what the nuances are, and even just start using the correct title for what it is you want. You'll be a lot more successful. Because software architect, solutions architect, very loaded, very generic term, means different things in every company. Learn your basics first, and then communicate to the world what it is exactly that you want.
Yeah, that is an amazing advice, I would say. Like, you have covered like a lot of things, And that brings us to end of this amazing episode. Like I really enjoyed talking to you, and then like we touched like a lot of topics, and like we went into details, and like it was very insightful for me as well. Like I have learned a lot of things from you. You have like amazing expertise in software architecture design, and obviously you are in the market for 15 years. So yeah, it was my pleasure having you on the show.
Huzaifa, thanks for having me. Thanks for inviting me. I enjoyed it a lot. To our viewers, thank you for
Yeah,
watching us all the way to the end.
yeah,
Thanks.
yeah. To all the viewers, just keep learning, keep just learn about yourself as well, like what you actually want. Just don't just focus on like, okay, I want to do this. Just get to know about yourself as well, and just keep learning. And until the next video, have a nice day. Bye bye.
Bye bye.